Hello, my name is Umakant. I'm an aquaculture consultant. Welcome to our video on sustainable aquaculture technologies, featuring the innovative In-Pond Raceway System, or in short called as IPRS, a revolutionary method transforming aquaculture with superior ecological and economical sustainability. IPRS is not just advanced technology. It's a balanced approach integrating economic growth, social responsibility, and ecological preservation. It efficiently utilizes water, land, and energy resources to create sustainable aquaculture solutions. Sustainability needs to be achieved in both economical and ecological aspects. Economic development or benefit should be there individually as well as to the society. In terms of ecological sustainability, core aspects like water conservation, efficient utilization of land resources, and environmental aspects should be addressed properly. If any technology that can address all these above-mentioned sustainability aspects efficiently, that technology should be adopted widely. Compared to traditional methods, IPRS technology multiplies productivity by 6 to 8 times, reduces disease occurrences, optimizes manpower, and achieves near zero effluent emissions. Let's try to understand the sustainability perspectives of IPRS technology. In terms of economical sustainability, when compared with traditional fish farming practice, as I mentioned, with IPRS technology, the productivity can be enhanced by 6 to 8 times. In terms of ecological sustainability, In-Pond Raceway System is equipped with efficient solid waste recovery system, because of which the resultant organic effluent emissions from the culture system becomes near zero. Concept of separation and zonation of 80% fed species to 2.7% of culture area and stocking 20% survey species in the remaining 97.3% of culture area as plankton utilizers results in efficient utilization of feed and nutrients. Due to usage of continuous and efficient aeration and water circulation in the entire pond, water quality is well maintained, which leads to lesser water quality management expenses. Due to better water quality and efficient management of effluents, chances of disease occurrences are very less, and needs for frequent water exchange will not be there. In this way, our objective of efficient water resources utilization is attained. So by the adaptation of IPRS technology into pond aquaculture, all the sustainability goals like better utilization of land, manpower, water, and energy resources are attained. If you are considering adaptation of IPRS technology, evaluate your readiness based on capital investment, operational demands, and potential economical returns. With the adaptation of In-Pond Raceway System into pond aquaculture, the efficiency of the system gets improved in a sustainable manner. But adaptation of IPRS technology involves reasonable amount of capital investment, so you need to do a thorough assessment before taking any big investment decisions. Let's try to assess the cost implications in the coming slides. Initial setup of IPRS system involves costs related to pond construction, civil infrastructure, specialized equipment, power systems, and warehouses. These are significant investments crucial for your long-term success with IPRS system. IPRS system involves high capital expenditures like construction of new pond or modifying existing pond, civil construction costs for constructing raceways, cells, sludge settlement tanks, and other infrastructure. Costs for other core equipments like airlifting units, bottom aeration system, sludge removal system, pumping motors, standby generators, electrical power infrastructure, fish confinement gates, feed storage systems, feeding systems, monitoring and surveillance equipment, etc. Let's try to understand the operational costs involved with IPRS technology. You are well aware that IPRS technology is intended for getting a higher production per unit area. So basically, with higher productions, you need to give more inputs into the system so that the output also will be more. You can expect more expenditure in terms of feed, seed, and energy and other equipment maintenance costs. So imagine if you are targeting a body weight of 1 kilo and a biomass of 20 metric tons production per cell per cycle. So for that, you need to stock nearly 20,000 figurines. And again, you need to use nearly 30 metric tons of feed to get that 20 metric tons of production. So again, you have the equipment maintenance costs involved in the system. So because these are all 24/7 running systems that are going to be used in IPRS technology, so the regular maintenance costs will be there. But in the same way, there are some costs where you can see a reduction. When you look at the water quality management cost, there you can observe a drastic reduction when compared with the traditional pond-based fish farming system. Again, in terms of manpower, you can see a drastic reduction in terms of your investment because you are going to produce more fish from less area. So these are the components, operational components involved in IPRS technology. Okay, now you might be thinking about whether I can adapt IPRS system or not. So where to start from? So you need to begin with a comprehensive economic analysis, assess the market dynamics, and calculate the minimal profitable return to ensure feasibility. So before taking the big investment decision, a thorough study is essential to assess the feasibility specific to you. Let's see how to start off. Okay, you have to do a thorough economic analysis before venturing into IPRS adaptation. Carefully conduct preliminary financial assessments to gauge profitability. Proceed only if the numbers clearly promise sustainable returns. Market assessment is the first thing that you need to do before taking any investment decision. What are the opportunities? Can you sell your fish locally or you need to export it? What are the culture species that fetches better market price? What is the supply-demand scenario in your market? Whether the market opportunity and the profitability are sustainable? Analyze the data. Find out what is the least possible profit you can make per kilogram fish produced. Work out return on investment. If the numbers are looking good, think about adopting In-Pond Raceway System. If the numbers are not promising, hold on. Redo the analysis. Still the numbers are not promising. Please don't proceed. If the numbers are looking good in your preliminary assessment, the next step is to identify the culture species. So list out the culture species that are available and find out their farm gate prices and prioritize the culture species. This is the first thing that you need to do. The next step is to find out whether the selected species got established standard operating procedures for culture. Does that species consume formulated floating fish feed or not? Can you get ample species-specific diet in your area? The market opportunity and profitability should be sustainable at least until you attain ROI. After all these assessments give you a positive sign, then only take the final investment decision. With the financials out of the way, let's now talk about the methodology and concept of IPRS technology. Before jumping into the details of IPRS technology, let's try to understand the biological and biochemical processes involved in traditional pond aquaculture so that we can better understand about the IPRS system and its advantages. In general practice of traditional fish farming, we normally stock fish in the entire pond water spread area. So feeding, excretion, decomposition, and planktonic cycles happens in the entire pond water spread area. Imagine if you stock 10,000 fish in a 1 hectare culture pond with a 2-meter water depth, then it will be around 1 fish stocked per 2 cubic meter water volume. So to provide ample aeration to that one fish, you need to make sure that 2 cubic meter water area is optimally aerated, and the same principle applies for any water treatment approach to control any disease or any water quality management aspects. Imagine for an estimated production of 10 metric tons of fish from 1 hectare, you might be ending up using nearly 15 metric tons of feed. So if you compare the feed and the fish production on dry matter basis, 15 metric tons of feed, when you remove the moisture, the dry matter value will be around 13.5 metric tons. So in the same way, if you remove the moisture from the biomass fish production, that is 10 metric tons, if you remove the moisture, then the biomass will be 3 metric tons in terms of dry matter basis. It means that nearly 10 metric tons of organic dry matter gets accumulated and it gets processed in the pond during the culture cycle. All this organic load pulls down the production potential of the pond system. In-Pond Raceway System is a wise conglomeration of various smart solutions gathered from different culture systems adapted into pond aquaculture system for improving the productivity from unit area in a sustainable manner. Creation of specific zones for specific purposes, inclusion of controlled water flow and aeration mechanism, solid waste recovery system, efficient utilization of pond area as a natural biofilter. These are the core concepts of IPRS technology. The designers adopted different culture technologies into In-Pond Raceway System to make it efficient and a sustainable technology. The technologies that they adopted, the first one is confining the target culture species to raceways, which is adapted from hill stream raceways. In IPRS technology, the entire culture species, target culture species are going to be stocked in the raceways, and these raceways occupies only 3.7% to 4% of the total water spread area of the pond. And the second one is constant water flow through system. In the raceways, the water exchange happens at every 8 to 10 minutes at the rate of 100% water exchange. This water exchange concept is again adopted from hill stream raceways. And the next technology what they adopted is specifying zonation in the culture system. Like you have a special grow out zone and then a sludge recovery zone and a biofiltration zone. So these concepts were adopted from recirculating aquaculture systems. So In-Pond Raceway System was designed in such a way that it creates a controlled water flow within the pond, which significantly enhances waste management and biofiltration efficiency. By isolating production zone, aeration zone, waste management zone, and biofiltration zone, solid waste collection and efficient utilization of nutrients from dissolved solids is attained. In this manner, In-Pond Raceway System provides a sustainable solutions to the limitations that hinders the productive enhancement in traditional pond culture. Let's try to understand more about the key structural components involved in In-Pond Raceway System. In-Pond Raceway structure comprises distinct zones, a compact and efficient production area, a specialized aeration zone, and a dedicated waste recovery areas, significantly boosting operational efficiency. Let's try to learn more about the cell and different zones in In-Pond Raceway System. Generally, for each 10,000 cubic meter water volume, one raceway cell can be constructed. For example, in 1 hectare pond with 30,000 cubic meter water volume, 3 in-pond raceway cells can be constructed, which occupies nearly 450 cubic meter area. Concrete cells with open ends on both the sides are constructed inside the pond adjacent to one of the dikes. First 2-meter area at the entry point of each raceway cell is known as aeration and water flow generation zone. One airlifting device called as whitewater unit will be installed for each cell. This whitewater unit occupies nearly 25 cubic meter area out of the total cell volume. Key production zone or fed zone starts right after the whitewater unit. 2 fish confinement gates are placed between the whitewater unit area and fed zone to hold the fed fish within the production zone. 22-meter long fed zone extends into the quiescent zone or feces settlement zone. Before and after the feces settlement zone, 2 more fish confinement gates are in place to hold the fed fish within the fed zone and to avoid service species entering the quiescent zone. A biofilm wall will be in place right after the quiescent zone or feces settlement zone in order to make the water existing from the cell to take a longer path. 3 to 4 whitewater units are placed across the pond to maintain aeration and water circulation. Let's dive deep into more details. Fed zone, the key production zone, is compact yet highly productive, facilitating feeding, treatment, sampling, and harvesting operations with a lot of ease. Target fish species are confined to fed zone in the raceway. This fed zone occupies only 2.7% of the total water spread area of the pond. And the second one is aeration and water flow generation zone, which occupies nearly 25 cubic meter area out of the total cell volume. Whitewater units are installed in this zone with a 3 HP blower support. Quiescent zone or feces recovery zone. Final 6-meter length of the raceway cell is designated as quiescent zone or feces recovery zone. This zone is equipped with a specially designed sludge pump powered with 3.2 HP sludge motor. Now I'm going to brief you exactly the flow process involved in In-Pond Raceway System. At the entry point of the cell, you have the aeration and flow generation zone. Whitewater unit is fitted at this zone. Water gets sucked by aeration grate in the whitewater unit and air gets mixed into the water while traveling towards the upper hood of the whitewater unit. By the time the water touches the hood, water is fully aerated. When the water touches the hood, because of the angle of the hood, the water flow changes direction and gushes into the fed zone of the IPRS cell. Because of the power of the blower, the water flow will be very high, so it pushes all feces and solid waste towards feces recovery zone. At the end of feces recovery zone, there is a knee valve which stops solid waste getting out of the zone. When the sludge pump gets operated, all the waste will be sucked out of the feces recovery zone. This process continues until you harvest. Let's try to understand more about whitewater unit and how efficient it is in terms of energy utilization. Basically, whitewater unit contains 3 key components: aeration grate and a hood and air blower. So these are the key components in whitewater unit. Normally we use 3 HP air blower for whitewater unit. This 3 HP air blower releases high volume, low pressure air into the diffuser grate. So, and this diffuser grate produces small rising air bubbles. Air bubbles pushes the water upwards. The smaller air bubbles, the higher the surface area they'll have. Depth of the diffuser grate and the placement of the hood determines the water thrust and flow. Hood and its angle provides maximum water thrust into the cell. In regular pond environment. Major sinks of dissolved oxygen are the phytoplankton and the benthic respiration. Typical aeration in open pond culture system is inefficient because much of the oxygen produced is used up by organisms other than the fish. Whereas in IPRS system, by providing aeration directly to the inflowing water of the raceways, the oxygen is efficiently delivered directly to the fish contained therein the raceway cells. Let's try to understand more about raceway cells and how they are efficiently helpful for us in terms of utilizing the resources. Raceway cells, especially the fed zone or production zone or fish confinement zone, is around 22 meters long, 5 meters wide, and 2 meters deep. The fed zone, production zone, or you can call it as fish confinement zone, volume will be around 220 cubic meters. The fed zone, production zone, or fish confinement zone walls are very smooth, and even the floor is very smooth and flat, so that it can facilitate smooth water flow and helpful in terms of doing harvesting operations. Fishes are fed and grown in this zone. Feeding is provided only in fish confinement zone. Fed species are restricted to fish confinement zone, and no feed is offered to fish outside of the fed zone or fish confinement zone. Fish are harvested from here. Water flow in this fed zone flows at the rate of 6 to 8 centimeters per second. It means 8 to 10 water exchanges per hour happens in this zone. Because of this gushing water flow, fecal matter gets pushed towards the feces recovery zone. So, what are the advantages by having these raceway cells? Because of their small operational area, you can have an effective contact area for fish and feed. You can do feeding behavioral observation very easily. You can practice even staggered stocking method. You can even grow juveniles, and you can do easily sampling and harvesting operations. And even if you are doing a live fish marketing, it's very easy to handle because of this small operational area. And even disease treatment, if at all any disease occurrence happens accidentally, treatment process is very easy because all the fishes are accumulated in a 220 cubic meter area. So it's very easy to do any treatment to these fishes. Let's try to understand more about the sludge or solid waste recovery system and how it is helpful for us in terms of efficient nutrient management. So in general, when a fish takes any feed pellet, nearly 30 to 40% of the nutrients out of the total diet it takes in can be digested and ingested. So remaining 60% comes out as a fecal waste. So again, out of the total fish waste that comes out of fish, the thing that can be collectible, which is in solid form, will be around 30 to 40%. So the remaining 60% or 70% gets dissolved into the water. So you cannot recover that liquid dissolved waste. So with the quiescent zone or fecal recovery zone, what happens when the water runs continuously in the race vessels? It pushes fecal matter continuously into the quiescent zone. So this is the biggest advantage of IPRS system. With this mechanical collection of solid waste, you can reduce the organic load that is building up in the pond. If managed, collected solid waste can be converted into an income also. if you can be able to manage it properly and you can convert it efficiently, you can make it as an side income source. So waste solids in IPRS are systematically collected in designated quiescent zone, significantly reducing organic loading in the pond environment. So this quiescent zone is located at the downstream end of the raceways. It is common for all adjacent cells. The 6-meter long quiescent zone is bisected lengthwise by a low-level partition with a width of 25 to 30 centimeters and a height of 25 to 30 centimeters. This partition acts as a physical separation for the two solid removal devices which are installed for solid waste removal from within this quiescent zone. The next important component in IPRS system is the bottom or supplementary aeration system. So, bottom or supplementary aeration system ensures adequate oxygen supply, critical during peak biomass production and challenging environmental conditions. Bottom aeration or supplementary aeration system is arranged parallel to the wall at the base of the cell wall. Diffuser tubes are arranged which are connected to the blower through an aeration tubing and a PVC pipe. This bottom or supplementary aeration system is useful when fish farming is near to peak biomass and also during treatment times. Especially for higher density cells with more than 20 metric tons biomass, this is very helpful. A 3 kilowatt blower can be installed for a 4-cell IPRS system, which can increase the dissolved oxygen level by 0.5 milligrams per liter. A 4.3 kilowatt blower can also be installed for a 4-cell IPRS system, which can increase the dissolved oxygen level by 1 milligram per liter. Bottom or a supplementary aeration system should only be installed up to the first 15 meters length of the raceway cell. The next crucial component in IPRS system are the fish confinement gates. The fish confinement gates efficiently segregate fish within specific zones, allowing controlled management, harvesting, and minimizing the fish escape. Fish confinement gates function to contain the fed species within the fed zone or production zone of the raceway cell, located at the most upstream and downstream parts, that is the head and tail end of fed zone or production zone. The fish confinement gates not only retain the fish but must also facilitate water flow through the raceway system. The material used to build the gates are important. Metal 304 stainless steel, fiberglass or similar strong but lightweight material forms the gate frame. The material that actually confines the fish is either PVC coated steel wire, such as it is used in marine crab or lobster traps, or a 304 stainless steel wire mesh. Because the materials are expensive, it is best to optimize opening dimensions and minimize the area occupied by confinement materials. Galvanized and similar mild steel or plastic mesh is not suitable and will fail quickly. Netting mesh, like knotted, is likewise not recommended due to its rapid failure rate and aberration on the fish. The next important component in IPRS system is the baffle wall. So let's try to understand more about the baffle wall and how it is helpful in reconditioning the water quality. Strategically placed baffle wall direct water flow, enhancing the biofiltration efficiency and maintaining optimal water quality throughout the production cycle. The baffle wall usually extends across the pond diagonally, but pond configuration will dictate its location. It is important to leave a gap between the end of baffle wall and the nearest levee, that is at least 300% of the total width of the IPRS setup in the pond. A baffle can be made out of fabric or mud and is placed along the longitudinal axis to force the water to take a longer course around the pond before returning to the system head. The baffle wall acts to direct and guide the flow of water coming from the IPRS cells around the full length and width of the pond. The baffle wall and the whitewater units installed on the raceway cells and in the open pond locations functions together to move, mix and aerate the whole pond, allowing the biota of the pond to more rapidly assimilate the waste load placed on the pond. So let's try to summarize the advantages of IPRS technology. IPRS technology provides multiple operational advantages, including efficient land resources usage. You can stock multiple species, multi-age stocking you can also do. You have the ease of feeding with this IPRS system. You have the convenience to monitor fish very closely. Because of very smaller operational area, you can reduce the labor cost. You can consider a very low or no chemical usage with IPRS system, and you have low chances of disease occurrence in IPRS system. You have the ease of sampling and ease of harvesting. With IPRS system, you can attain low feed conversion ratio. You have the ease of partial harvesting and grading, and you have the advantage of collecting waste out of the system and making it a financially viable side income. And you have high chance of getting better survival with IPRS system. You also have the advantage of getting production from unfed zone by utilizing the natural productivity of the pond, and you have the advantage of an efficient utilization of energy and resources, and you have also this advantage of controlling the predator incidences, because you are confining your fish to a fed zone where the predators cannot even enter into the system. So in conclusion, the In-Pond Raceway System is a proven, sustainable solution and enhancing productivity, profitability, and environmental care in aquaculture. Evaluates its financial feasibility, master its technical requirements, select the right species, and adhere to standard operating procedures to get succeeded with IPRS technology. Take proper advisory service for the technology adaptation and implementation. Thank you very much for joining with me to explore the advantages of In-Pond Raceway System. For further information or expert consultation, please reach out to us directly. For technical support, advisory, and consultation support, please contact me. Please find the contact details below. Thank you very much.